This is my problem 7a, and originally I stopped solving for the field with the variable that was not given directly in the problem. So when I was solving this one for my test corrections, I started by writing down what was given in the problem, just kind of redrawing what was given. And then the first thing I did was I drew the field, and I knew that field points from high voltage to low voltage, so from this up. So it goes in the plus y direction, it's positive. Then I was remembering that Newton's second law says that the electric field and the magnetic field have to equal to 0 in order for the electron to continue straight through this without being directed one way or another. And then I found what the direction of the electric force was, because this is F equals QE is the equation for this, and you can solve for the direction of F by seeing how the two charges would multiply, and since Q is negative and E is positive, the force of the electric field is negative. So I drew this with kind of a miniature free body diagram. It'd be going down, and then from this I made the conclusion that the magnetic field must be up in order to cancel this electric field going down. So that's how the signs I'm going to continue using. And then I remembered that the equation for the force from a magnetic field is QVB sine theta, and that sine theta is the angle between V and B, and the angle between V and B in this case is 90 degrees, which makes sine theta 1, which I will show when I get to a certain point. And then I kind of continued with the Newton's second law idea and showed that the force from the electric field is negative QE plus the force from the magnetic field is QVB sine theta is equal to 0. And then I just solved so that they're both positive and separate. And I saw the Q's could cancel, so I did that. And then at this point is where I showed that sine theta would just be 1, so I'm not including it from now on. And I'm left with E equals VB, and I know that E is V naught over D, so I plugged that in to the E, and then I solved for the field and got V naught over dV. And then for the direction, I'm going to try to do this while I'm holding my phone, but I don't know how it's going to go. I know that it goes by the floppy wrist right hand rule, so my fingers have to go left. Oh dear. Fingers have to go left, and then I'm trying to figure out where my palm's going to go, because that's with the floppy wrist right hand rule, the direction of the field. But I know that I want my thumb, which is the force, to be down, because since it's an electron, what I want it to be has to be the opposite of what my hand shows. So I want my thumb to actually be down since the force is up. So I went like this, down, and that means that my hand's going this way with my palm, so that means that the field is in, so it's in.